Using stored routines for administration. The previous two nuggets, one on stored procedures and two on triggers, are culminating in this particular nugget. And the reason I structured it that way are for at least three really good reasons. Number one, we have a much better grasp now that we're going to look at using those stored routines for security purposes and best practices in MySQL administration. Number two, if you decide to go in some other directions with your MySQL certification, in particular, if you want to become a certified MySQL developer, you'll need to know details about creating and managing both stored procedures as well as functions. And by covering the nuggets in this series, you'll have a really nice head start. And third, in the real world, in order to be a well-rounded DBA, not only for MySQL, but for any major RDBMS platform, you should know about stored routines. Now then, in this particular nugget, we're going to look at how to enhance security in using stored routines. In particular, we're going to focus our consideration on a particular kind of stored routine that we're familiar with by now, the stored procedure. We're then going to look at how stored procedures improve performance for MySQL in a variety of different ways. Let's get to work. Stored procedure security. Now listen up, folks. This is some really useful information, not only for MySQL, although of course that's what we're dealing with in particular here, but for any RDBMS. You'll recall over the previous couple of nuggets, I made reference to and described a little bit a very important attack that a lot of bad guys try to exploit called SQL or SQL injection. And I mentioned that the chief way to block this kind of exploit or this kind of attack against a web application that relies upon an SQL database is to sanitize the code coming into the database. And one great way to do that is to encapsulate your logic using stored procedures to make sure that any data coming into the database is squeezed into a stored procedure. Now, on a more global best practices suggestion, a lot of DBAs, including myself, subscribe to the general principle of severely limiting end-user access to base tables. In a relational database system, of course, at the lowest level of your database schema or structure, you have the table. And this is where your data is fundamentally stored. And obviously, that's some really sensitive information from a structural standpoint, from a data integrity standpoint, from a normalization standpoint, from a security standpoint. Therefore, there's different things we can do as database administrators, database designers, database developers, etc., that can protect these base tables. We can create views and grant users access to these views. That's not our consideration here, though. Another thing we can do is use stored procedures to control access to those base tables. Now, in stored procedure logic, we have in the definition of a stored procedure, you'll remember in the previous nugget where we looked at the create procedure statement, there are some extensions that I didn't tell you about then that I'm going to tell you about now. One is the definer clause. And notice that definer, it's an optional clause actually. It comes right between create and procedure. It's kind of interesting how it shows up right in the middle. Now, if you don't include definer, like we didn't in the previous nugget, and just issue create procedure, then the procedure is created under the security context of the current user. So if you've logged on as root, then the owner or creator of the procedure is the root user. Now, if you want to create the procedure under the security context of a particular MySQL user, you would throw in the definer clause and then add that user account explicitly after it. Under most circumstances, the creator is fine, provided it has at least the execute permission. Because unless you specify another clause, the SQL security clause, Now that comes after procedure. The procedure will be run in the security context of definer. And in this case, the definer would be a super user or some administrative user. However, SQL security or SQL security is an important clause if you want to shift the security context of a stored procedure. Now, this can be awfully useful for a variety of different scenarios. Now, consider this scenario, and this is actually the scenario we're going to look at in the upcoming demo. Let's say you have a MySQL user, and you do not want that user to have any access to your base tables. So if that user were to try to run a select statement against those base tables directly, forget it. It's just not going to work. However, through your application code, that user can, because you've granted that user the execute permission on those base tables, the user can use that stored procedure to access the base tables through that proc. You see what I'm saying? This is an excellent best practice for using stored procedures to enhance security. So the definer characteristic denotes the creator. The execute permission is given to those for whom you want to allow to run or call the stored procedure. The SQL security clause determines under whose security context you want the procedure to run, whether it's the definer or the invoker. Now, if you don't include an SQL security clause, the default is the definer. So this is a special case down here where we're creating a definer of admin at localhost, and we're defining the procedure called account _ count, SQL security invoker, and then in the begin end block, this is a simple select statement that grabs some data from the mysql.user table. Now this is kind of the opposite of what I was talking about up here. Up here we're talking about a user that we don't want any access directly to our base tables, but we're granting execute to the procedure, and because the stored procedure is executing in the SQL security context of the definer, the procedure does have access to those base tables, and we're fine. Now the other way to go is where the user may or may not have access to base tables, but when the user executes the stored procedure, if the stored procedure is running under SQL security invoker, this makes the stored procedure more dynamic. Because if user A runs the stored procedure is kind of customized permission-wise to the security context of user A. If user B runs the stored procedure is going to return rows that are relevant to B. Therefore, I'm really a fan, actually. I find this a very elegant way to work. So to come back to what I was saying, therefore, to repeat my main point, between creative use of the definer and SQL security invoker or definer, you can really be flexible in how stored procedures work to enhance the security of your MySQL tables. Enhancing performance with stored procedures. We're retreading a little bit on a topic that we covered in a previous nugget where we formally discussed stored procedures. However, this bears repeating because you're likely to see this information on your DBA2 certification exam. Now, our goals in enhancing performance across the board, but particularly in terms of query performance with MySQL, are twofold, aren't they? Number one, we want to do whatever we can to reduce network bandwidth. We want to do whatever we can because MySQL is in fact a client-server application to minimize clogging our pipe, our network pipe, between the MySQL server or servers and our users. Second, we want to do what we can to reduce network latency. Latency being defined as delay. One thing I've found is a truism working for the past several years as a DBA and systems administrator is that users are next to never satisfied with their speed of service. No matter what you do to tweak up speeds and make things and make services as blindingly fast as possible, there'll always be folks complaining, why is the system so slow? However, we can just keep on plugging on, right? Now, how do we attain these goals that we just mentioned? One is just being ultra vigilant and implementing stored procedures as much as possible. Because as I alluded to in the previous nugget, and I'll repeat now, a stored procedure by its very nature encapsulates one or more SQL statements into a single compiled code module that's called with a single statement. Therefore, you can take 1, 200, or perhaps hundreds of statements that would otherwise have to float over the wire serially, one after the other, and break those down into a single statement, thereby saving what could be a tremendous amount of network bandwidth. That in itself is worth the price of admission, as far as I'm personally concerned, in terms of you learning how to leverage stored procedures. Another great benefit and performance enhancement with stored procedures is, of course, the fact that my SQL server on the back end has this component called the Query Optimizer. And so once it intercepts and processes that stored procedure and generates an execution plan for it, it stores all of that information in cache, in memory, such that the next time someone issues or calls that stored procedure, my SQL server can run that stored procedure far faster than it could otherwise. In our demonstration, we're going to experiment with execution context and stored procedures. In a nutshell, what we're going to do is create a standard MySQL user and grant that user the execute permission. We'll create a proc and then demonstrate that while that user cannot access the world database normally by selecting against it directly, he or she can use the stored procedure to do the same. All right, let's begin this demo on LinNugget 1. As you see, I'm logged into MySQL. I'm logged in as the root user or super user. And as stated previously, we're going to begin by creating another user, just a standard typical user. I'm going to use the MySQL command create user to do this. I'm going to create a user named Nigel, and we'll define his connectivity to the local host. His password will be defined with the very unsecure but simple, easy to remember password. We'll then grant the execute command to all objects in the world sample database to Nigel. Let's verify now using the show grants command. And of course we have grant usage, which is automatically given to any MySQL user that's created. This is going to allow Nigel to log into MySQL server and run a show databases. That's about it. We have a hashed password. We know what the password is in clear text, though. And then we've manually granted the execute permission on all world database objects. Okay, good. Next, what we're going to do is use the world database, and we'll create a simple stored procedure. It doesn't matter what the procedure is. This one will actually be very similar to the sample procedure we did in the earlier nugget where I taught you how to do stored procedures. All right, I'm using the delimiter keyword to change my delimiter to something arbitrary. This procedure is called record count. You'll notice that I'm leaving the defaults here for the definer clause as well as SQL security clause. That is to say, my definer clause is going to be root, and my SQL security clause is going to be definer. The defaults are perfectly fine in this case because I want the procedure to run in my security context. That is to say, the root security context. All right, now before I go any further, of course, I have to make sure that I set the delimiter back to the semicolon. Another command you might want to be aware of is a show command called show create procedure. It's an excellent way to get a run of the code behind your stored procedure. Show create procedure, you can qualify it with the name of the database. You could say, in this case, world.recordCount, Or if you're already attached to a database by using the use command, you can just specify the name of the database. I find it helpful to use the escape character \G to get a vertical row display. And this gives you here a field called create procedure that gives you the full code here. So we have create, and then we have the definer thrown in, and it's telling us, of course, root at localhost is the owner of this. And then we have the actual code, no big surprise there, and some additional information regarding character sets. All well and good. Okay, I think we've done everything we need to as root. So let's \Q to log off, and let's log on now as Nigel. And we'll provide that simple password. We can verify that we are logged on as Nigel a couple of different ways. We could run show process list, or we can select against the current user function to verify we are in fact Nigel at localhost. Why don't we try a select count against the world.country table and see if that works. Sure enough, as expected, the select command is denied to Nigel for the table country. And you know why? Because as previously known, we can just run show grants now to see our own grants. We have usage and we have execute on world. So we don't have any privileges against anything really on any database, including world. We can use world. That's fine. Let's show tables. Can't even show tables. But we can call record_count, and drum roll please, it works. Remember that record count, all that procedure did was return a row count from the country table. So thereby it proves the fact that even though this Nigel user has absolutely no privileges to any of the database tables, he can run the stored procedure, and the code inside that stored procedure is able to run because the stored procedure is running in the context of another user. There it is. Finally, let's see if Nigel can be sneaky, and let's say he wants to run show create procedure record_count \G to try to get jiggy with it and see the code behind that stored procedure to kind of footprint what's going on behind the scenes in that stored procedure. MySQL is smart enough to selectively disclose only information that it feels that this user has privilege to. And essentially it's nothing. It returns a null for the create procedure field. Pretty slick, huh? Using stored routines for administration review. In this nugget, we looked at a couple of different ways that we can leverage stored routines, stored procedures in particular, to enhance security in MySQL 5.x. I then also gave you some tips, which is an exam alert for sure, for improving performance in MySQL, again using stored procedures as a base of operations. I hope that this has been informative for you, and I'd like to thank you for viewing.